For questions 1, 2, 3, and 4, you're just determining if the side lengths can make a triangle. So we're going to do that by taking the two smaller sides and adding them together. So for this first one, it would be 2 plus 3. And then we're asking ourselves, is that greater than the third side? And since this one is not, it would be 5 is greater than 5. It's not true. This is not a triangle. For the second one, the largest side is 14. So I'm going to add the two smaller sides, 7 plus 8. I'm asking myself, is that greater than 14? It's 15, so yes, it's greater. So yes, it's a triangle. For the next one, I'm going to add 3 plus 4. I'm asking myself, is that greater than 5? The answer is yes. So yes, it's a triangle. And for the last one, all the sides are the same, so I'm going to add 2 of those together. Asking myself, is it greater than the third? It is, so yes, it's a triangle. 5, 6, and 7, we're using what we're given to determine the order of either the angles or the sides from largest to smallest. So for number 5, we're given side length. So if you look, this side is the largest. It's across from angle B, so angle B is the largest angle. 4 is the next largest. It's across from C, so angle C would be the next largest angle. 2 is the smallest. It's across from A. Angle A would be the smallest. Very similar, but just working in the reverse order. For number 6, we're given the angles. So the angle that is labeled 110 degrees is the largest, and that angle is across from this side, which we would call AB. The next largest angle is angle B, which is across from this side, named AC. Or if you called it CA, that would be fine too. The smallest angle, A, is across from this side, CB. Or again, you could call it BC, and that's completely fine. Number 7 is very similar to 6. The only difference is it doesn't give us angle A. So we're going to start off by solving for angle A. So I have 90 and 75, which is 165. 180 minus 165 is 15. So this angle would be 15 degrees. And then from there, I'm just starting with the largest angle, which is 90. It's across from AC. The next angle that's the largest, 75, across from side AB. And lastly, 15 is across from side BC. From there, we move into our isosceles and equilateral triangles. So this first one, number 8, says triangle DEF is equilateral. That tells us that each of the sides is the exact same length and each of the angles are congruent. If all 3 angles are congruent, remember there's 180 degrees in a triangle. If we divide that by 3, each angle is 60 degrees. So angle F is equal to 60 degrees. So 3x plus 30 equals 60. We can subtract 30 from both sides. 3x equals 30. Divide by 3. X equals 10. For number 9, triangle QRS is isosceles. That tells us 2 sides are the same. It also tells us that the base angles are congruent, which are these 2 angles here. So knowing that, we can take those 2 equations, 4x minus 20, and set them equal, so 2x plus 20. And then we can solve. So I'm going to start by subtracting 2x from both sides. 2x minus 20 equals 20. Add 20 to both sides. 2x equals 40. Divide by 2. X equals 20. Make sure you're reading carefully because it says solve for the measure of angle Q. So I actually need to take this 20 and plug it into one of these angles. So I'm just going to plug it into angle R. So 4 times 20 minus 20, that's 80 minus 20, which is 60. So this angle is 60, which means this angle is 60. 60 plus 60 is 120. I need to have 180 total, and that gives me 60. So angle Q is actually 60 as well. A lot of people in class have said, okay, but that makes it equilateral, and it said isosceles. I just happened to pick these numbers, and it just ended up working out this way, so that's an error on my part. Your math, if you get this, is completely correct. Then for this next one, number 10, XYZ is isosceles. So again, that means that two sides are the same, and it means that these base angles are congruent. So if Y is 5x minus 40, so is Z, which then allows us to add all these angles together. So 5x minus 40 plus 5x minus 40 plus 10x plus 20, and we know that angles of a triangle always add up to be 180 degrees. So I can combine my like terms. So 5x plus 5x plus 10x is going to get me 20x. And then negative 40 plus, minus 40 plus 20 is going to be negative 60. I can add 60 to both sides. So I get 240, divide both sides by 20, x equals 12. For number 11, it says triangle PQR is isosceles. Again, that tells us two sides are congruent, and also that the base angles are congruent. We are trying to solve for angle R, which is this angle over here. So I know triangles add up to be 180 degrees. I can subtract out the vertex angle, which is 85, and I'm left with 95 degrees total. Since I know P and R are congruent, I can just take that, divide by 2, and I find out that R is 47.5. On the back, it's all of our favorite problem, the nesting triangle. When you're doing these problems, start with a triangle that has some information filled in. So personally, I'm going to go ahead and start with this triangle that's right in the middle. And in the description of the problem, it tells you that this is isosceles, which tells us the base angles are congruent. So I can take 180, subtract out my 27, that leaves me with 153. The base angles are congruent, so I'm splitting it in half. So that's 76.5. So this one is 76.5, and so is this one. There's lots of directions you could go next. Personally, I'm going to find this angle next because these two are a linear pair, which means they have to add up to be 180. So 180 minus 76.5 gets me 103.5. So this angle here is 103.5, and the exact same thing happens on this other side. I kind of have run out of information to use there, so next I'm going to go to this larger triangle because I have one of the base angles. The description also tells us this is isosceles, so we know those base angles are congruent. So if this is 35, over here we also have 35 degrees. Now you could figure out the vertex angle A up top. 35 and 35 is 70. If I subtract that from 180, I'm left with 110. So all together up here, A has to add up to be 110. So that might help us later. Right now I'm just going to leave it as is. Next, I'm going to go to this triangle that I'm highlighting in red. So this one, I have two of the three angles filled in. Triangles always add up to be 180. So 103.5 plus 5 gets me 108.5. And then if I subtract that from 180, I'm going to get 71.5. So this angle right here is 71.5. And if you haven't figured it out by now, we end up with like a bunch of congruent triangles on each side. So this triangle here is also the exact same as the one in red. So then the next thing I know is that right here, this angle that I put a blue dot in makes a linear pair with 71.5. So I can take 180 minus 71.5, which gets me 108.5. So this blue angle is 108.5, and the exact same thing happens over here. From there, I would look at this triangle that I'm highlighting in blue. Up in the directions, it tells you that this is equilateral. We know that equilateral triangles have all congruent angles, which means each one is 60 degrees. So right here we have 60 degrees, right here we have 60 degrees, and then this entire angle here is 60 degrees. So I have 27 plus 5, which is 37. If I subtract that from 60, I get 23. Now, kind of like the red triangles, we know they ended up being the same, so this angle right here and this angle right here are going to be the same. There are 23 total, so if I split that, I'm going to get 11.5 for each of those angles. Moving on from there, I can find this angle with the yellow dot right here because it is making a linear pair with 60, so to get that to add up to be 180, I would need 120. Same thing over here, this is 120. And then lastly, I have these really skinny triangles on the ends. I'm going to highlight it right here in yellow, so this one. And I can figure out that top angle because I have 120 plus 35, so that's 155. And 180 minus 155 is 25, so this top angle is 25 degrees, and the same thing happens on the other side. The entire next section is Pythagorean theorem. So again, Pythagorean theorem is a squared plus b squared equals c squared. A and b can be interchanged and it's not really going to mess anything up, but c always has to be the side that's across from the right angle. So in this first one, a squared plus b squared equals c squared. 3 squared is 9, 6 squared is 36, that equals c squared. 9 plus 36 is 45. And then to undo something that is squared, we take the square root. The directions say round to the nearest tenth, so the square root of 45, when you type it in a calculator, is approximately 6.7. For the second example, C is across from the right angle, so it's this side. A and B can be interchanged. So 5 squared plus b squared equals 14 squared. 5 squared is 25 plus b squared equals 196. And then I'm solving for b, so I have to subtract 25 from both sides. B squared equals 171. And the square root of 171 is about 13.1. On this last one, C is across from the right angle. Again, A and B can kind of be interchanged, so A squared plus 13 squared equals 25 squared. A squared plus 169 equals 625. Subtract 169 from both sides, and A squared equals 456. And then I take the square root of both sides, and I end up with A equals 21.4. For this bottom section, we are determining what type of triangle it is. So it's either going to be acute, obtuse, or right. Before you do that, you need to check and make sure that it is actually a triangle. So again, you make sure it's a triangle by adding the two smaller sides together and checking, is it truly greater than the third side? So for this first one, the answer is yes. Then to determine the type, you're going to put c squared on the left side. C is always the largest number. So 5 squared, leave a little space, and then you're going to put 3 squared plus 4 squared. Square everything, add those two together, and then kind of evaluate what you have. So is 25 less than 25, equal to 25, or greater than 25? They are equal. Since they're equal, it's a right triangle. 17, I'm going to start the same process. So I'm going to add the two smaller sides together. I'm going to check and see, is it truly greater than the third side? And the answer is no. So that means it's not a triangle. For 18, I'm going to repeat that process. So I'm going to add 10 and 16 because they're the smaller sides. I want to double check, is it truly greater than 25? The answer is yes, so it is a triangle. After I confirm it's a triangle, I take C, which is the biggest side, and I square it. I leave a space. I add a squared plus b squared together. So I end up with 625, and then 324 plus 100. I combine, and then I evaluate. So is 625 less than, equal, or greater to 424? So 625 is greater than 424, which makes it obtuse. Repeat the process again. So the two smaller sides added together. Is it truly greater than the third? Yes, so that makes it a triangle. Take c squared, which is the biggest, add a squared and b squared together. 22 squared is 484. 14 squared is 196. 17 squared is 289. Add those two together, so 196 plus 289 is 458. 484 is greater than 458, so this is obtuse. And then our last example, again, take your two smaller sides. They're all the same, so you can really choose whichever two you want. When you add them together, confirm that it's greater than the third side, which it is, so this is a triangle. Then I'm going to take c squared. I'm going to compare it to a squared plus b squared. So 16, 16, 16. Add those together and then compare. So 16 is less than 32, which makes this a cube. Don't forget, there is a quizzes posted, there is a Kahoot posted, the video right here for the review, and there's also just a plain key posted for the review, so you can use any of those to study for your test tomorrow.